Hello and welcome to the AI Research Roundup. I am your host, Alex. Today, we're looking at a paper called OmniConsistency. It tackles a common problem in AI image stylization, where you ask an AI to redraw a photo in a new style, but it messes up the details. This paper introduces a universal plugin to keep the image consistent. It's designed to work with what are called style low-rank adaptations, or LoRAs. A style low-rank adaptation is a small module that teaches an AI a new artistic style, and this new method helps prevent the style degradation that often happens when using them. And for those of you who want to try this method out, the authors have made the code public. On their GitHub repository, you'll find the complete implementation, Python usage examples, and links to download the main OmniConsistency model, plus a whole collection of those pre-trained style low-rank adaptations we just talked about. Alright, and this first figure really highlights the core issue and the solution. The top section shows an input photo of a couple, with the goal of redrawing them in a specific 3D character style. You can see that other methods, including one using ControlNet, which is a popular technique for guiding image generation, they struggle with what the paper calls style degradation and inconsistency. But the result from OmniConsistency on the far right is much cleaner. Then, the bottom section shows just how versatile this method is, applying styles like Picasso, Lego, and even origami to complex scenes, all while preserving the original structure. Okay, so after seeing those impressive results, this diagram breaks down how the OmniConsistency method actually works. It uses a really smart two-stage process. First, on the left, they train separate style low-rank adaptations for each artistic look, like 3D, cartoon, or clay. Then comes the second and most important stage, consistency learning. This trains a new, separate consistency low-rank adaptation inside a model called a Diffusion Transformer. A Diffusion Transformer is a powerful type of image generator, and by freezing the original style modules, it learns only to preserve the image structure, which is the secret to avoiding that style degradation. And this figure really drives home the power of that approach. What we're seeing here is a test of the model's flexibility. The top half shows results using style low-rank adaptations that the consistency module was trained on, what the paper calls scene styles. And as you can see, for styles like clay or Ghibli, it works perfectly. But the really impressive part is the bottom half. These are unseen styles, brand new low-rank adaptations that the model has never encountered before. And yet, it still maintains incredible consistency for styles like oil painting, sketch, and even architectural looks like a wasteland style. This next figure gives us a direct, head-to-head comparison against a range of other methods. Each row shows a different style being applied: vector, PVC toy, and sketch. And the columns compare different techniques, like standard image to image pipelines, where the AI modifies a starting picture against this new OmniConsistency approach. You can see that the other methods, even powerful ones like GPT-4o, tend to distort faces or change the composition. But the results from OmniConsistency, on the far right, consistently preserve those crucial details from the original photos. So, beyond those direct comparisons, this next figure highlights the plug-and-play nature of OmniConsistency. It shows how easily it integrates with other common tools. For example, the top row demonstrates text-guided stylization, where it uses a prompt to turn a photo into an anime scene, and it preserves the subject's poses much better. But the really interesting part is the bottom row. This shows the model working with a tool called an IP adapter. An IP adapter is a method that lets you use a separate image as a style reference. And again, the standard approach loses the composition, while OmniConsistency perfectly transfers the style. As we've seen, the OmniConsistency approach is incredibly versatile. By learning a universal concept of consistency, rather than just memorizing a few styles, this model offers a powerful and predictable tool for creative stylization. It really marks a significant step forward in making generative AI more reliable for artists and designers. Well, that's all the time we have for this episode. Thanks for joining me on the AI Research Roundup. I'm Alex, and I'll see you next time.